Myself, Dr. M. Laxmidevi, Associate Professor in the Department of CACDS at Institute of Aeronautical Engineering. In this video lecture, we learn about file operations in C programming language. So, what is a file? We have seen in the previous video lectures, we have discussed the concept of file. We have seen the definition of a file, and also we have seen some of the file related operations, that is how to read from a file, how to write from a file. So before performing reading and writing operations, we need to open the file and close the file. So after performing some input or output operations, that is reading or writing, so we need to close the file. So all this we have seen in the previous video lecture. In this video lecture, we will see some more file functions, file related functions. So these comes under file operations in C language. So what is the definition of a file? So file is nothing but it is a collection of data which is stored in secondary memory. So we require file. So file is a named location on a secondary storage device where data is stored permanently for later access. So whenever we want to retrieve the data as and when required, so we maintain the data in the form of files. So these files are permanently stored on secondary storage device. So file handling concept, it is a fundamental aspect of programming, so which enables data persistency and ability to exchange data between the programs and external storage. So as soon as we write the programs, so programs take the input and then give the appropriate result or output. But that output or input which we are given to the program, so that is not maintained. So as soon as we close the program, so the data which we entered is totally lost. So in order to avoid that, so we go for file handling concept. So key concepts in file handling, so these are opening and closing the files, then performing different operations like reading from the file, writing data to the file, and if there are any errors in the file, so that is tackled or handled by means of error handling. And also related to file handling, we have important concept, that is all these operations are done by means of file pointers. So these are the different file operations, or you can say file related file operations we need to perform. So first one, so in order to perform any operation on a file, so we need to open the file. So we'll see the syntax how to open the file, and then after performing appropriate operations or necessary actions on the files, so we have to close the file. So this we'll see in this closing the files. Next, the different file operations which we need to perform are reading from the file, then writing data to the file, and then positioning in the files. Suppose we want to access a particular position in the file, so that is done by some functions, file related functions. So that we'll see in this topic, positioning in files. Next is error handling. So what is error handling? So suppose we are opening a file in read mode, and if the file does not exist, then there should be some so then this type of situation are to be handled by means of the concept, that is error handling. Now let us see one by one. First one, the first file related operation, that is opening the file. So we have seen the syntax. So this is the function prototype. So here in the function prototype, name of the function is fopen. So fopen is the function which is used to open the file. So this is the syntax or prototype, you can say. So this is a prototype for fopen function. So it takes two arguments. So there are two arguments. So both the arguments or parameters, they are of character pointer. The return type of this fopen function is also a file pointer. So here these two parameters. So first one is the file name. So it accepts the name of the file which is needed to be opened. So the file which we wants to open, so that is nothing but the file name. Then mode specifies there are different modes in which you can open the file. So mainly these are the three important modes: read mode, write mode, or append mode. So read mode is it opens the file for reading purpose only. We can only read the contents of the file from the file. And then write mode is, so we can write to the file in write mode. And then append mode, so here also we can write to the file. But the way in which it is written, that is totally different in case of write and append. So next is closing the file. So let's see what is the syntax for closing, how to close the file. So so this is an important concept. So whenever you open the file by means of fopen function, so after performing necessary operations, you need to close the file. So in order to close the file, this is the function. So fclose. So at the end of the program, so you need to write this function fclose. So here it takes one argument, that is the file pointer. So here file pointer is nothing but it acts as a reference to the position in the file. So here the argument fp is a file pointer associated with the stream. So it returns 0 on success. So if the file is successfully closed, then it returns 0 and it returns EOF, that is end of the file, if it is a failure. So this EOF is defined in stdio.h header file. So it is defined in stdio.h header file and its value is -1. So we can detect the end of the file by using this EOF function, So when detecting the end of the file, so when you are reading from a text file character by character, we can check the end of the file character. When is the last character? So that we can do by means of EOF. So we'll illustrate it with the help of some sample programs. So this is how this is the prototype to close the file. Next is, now all this file related operations like fopen, fclose, they are all defined in the header file stdio.h header file. So this header file must be included in the program. So whenever we are performing file related operations. So all these functions, they are defined in stdio.h header file. Now other file input output operations. Now we'll discuss about file input output operations. So input operations and output operations. So we can do by means of functions which are defined in the stdio.h header file. So there are formatted input output functions as well as unformatted input output functions, file related functions. So formatted input output functions. So here we have fscanf and there are two important IO functions, fscanf and the other one is fprintf. So fscanf, so both these are formatted input output functions, formatted IO functions. So these functions are used to, so this is used to read the contents of the file and in formatted manner, and this fprintf function is used to write the data to the file by means in formatted manner. So we'll see the syntax one by one. So there are unformatted IO functions also. So these unformatted IO functions are get C, then put C, then other functions are, so these are unformatted input output functions. So which we'll be using for performing file operations. Then we have get S, put S, etc. So get W and put W. So these are the different unformatted input output functions which are available. Now we'll discuss each one by one. So first one is fscanf function. So it reads formatted data from the file. So next, one more function we have, fgets. So this reads the string from the file, one line at a time. So here fgetc. So fgetc, it reads a single character from the file. Next one is fread. So fread, it reads the specified number of bytes of data from the binary file. So let us see one by one. So first one, fgetc. So fgetc is used to read a character from the file. So it is useful for reading the data from the file. So the data is nothing but it reads a character from the file. And what it does is it returns the ASCII code of the character which is read by the function. So this is a function prototype. So it takes one argument. So that is file pointer. So whenever we open a file by means of, so in order to perform all these operations, first we need to open the file. So by means of using fopen function. So fopen function and the address of this file. So whatever we are opening, suppose we have the file test.txt. So this is the file to be opened. Suppose we are opening it in read mode. So this is the file pointer. Suppose fp is the file pointer. Star fp. So fp is a file pointer. So whenever you open the file test.txt, so if this is the test.txt file, so if it is opened successfully, then this fp will point to the starting address of this text file. So here it takes one argument. So in order to read a character from the file, so this is the input we have to give. It takes one argument, that is the file pointer. So next it returns an integer. So if, for example, suppose consider this example, ch is equal to f get c, where ch is a character. Char ch is equal to f get c fp, where fp is a file pointer here. So here fp is the pointer which is pointing to the very first character of the file. So it reads, so by means of this we can read the character from the current position, and then after reading from the current position, the pointer is advanced. The pointer position is incremented by 1. So variable ch will contain the character which is read by the function f get c. Now let us see another file input output another function, that is fscanf. So how to read from the file by means of using fscanf? So this function is used to read formatted data from the file. So whenever we say that formatted data, so formatted data means we have, so in the syntax we need to, so there we have format specifiers. So format specifiers, we know that, so there are different format specifiers for each of the data type. So %d is used for integers, %c is for characters, %s is for strings, and so on. %f for floating values. So in order to read the data, so this function reads formatted data from the file. So this fscanf function prototype is, we can say this is the prototype. So fscanf is the name of the function and it takes 3 arguments. So here it takes 1, 2 and 3. So this will depend upon the number of values the number of variables which you want to read from the file. So here ptr is a file pointer, and then this is a character pointer, and this one list is nothing but the number of values which you want to read from the file. So this function fscanf will read from the file which is pointed by the file pointer ptr. So instead of reading from the input stream, so it returns 0 if it is unsuccessful. So otherwise it will return the input string which has been read. Now let us illustrate the use of this function with the help of one program. So fscanf function, it reads formatted data from the file. So for example, consider this program. So here we have declared a file pointer. So name of the file pointer is file ptr. Then we have declared 3 variables. First one is name. So this one stores an array of characters which is nothing but a string. The second one stores the age, that is an integer variable. Age is an integer variable which stores an integer value. Then another variable we have height, so which stores a float value. So next, after declaring the values or variables, so first we need to open the file for reading purpose. So we have opened the file example.txt in read mode. So these are the contents of example.txt. So Joe 25 and 6.0. So now let us see. So if the file is opened successfully, so then we have to check whether the file is opened successfully or not. So with the help of these statements, we can check. So if the file pointer, so this nothing but it contains the starting address of the file which has been opened. So if it contains some valid address, then we can say that the file has been opened successfully. If it contains null value, then the file could not be opened. So that message has to be printed. And then return 1, it exits the program. So since this file exists, example.txt, so it will go to this line. So this line will be executed. So here we have used fscanf function, and inside this, so these are the different arguments which it takes. So first one is the file pointer. So as we have seen, the first argument is the file pointer. So that is indicated by file ptr. And then this after that, these the second arguments are format specifiers. So whatever values you want to read from the file, so for that format specifiers. So first one is a string, second one is age is an integer, so therefore percentage D we have used, and the last one is float value, so therefore percentage F. So all these have to be written in double quotes, then followed by the variable name. So percentage S corresponds to name, percentage D corresponds to age. So ampersand age, since we are reading, so therefore we have to put ampersand age. Then followed by percentage F is for height. So after that, after reading the values from the file, we need to close the file. So by means of using F close function. So it takes one argument, that is the file pointer. So here file pointer is file PTR. So next, after that, we are displaying the whatever the data we have read by means of using fscanf. So that data we are displaying on the screen. So by using printf function, so name is printed. So this is the output of this program. So at the end, we are printing whatever the data has been read from the file. So that data is printed on the screen. So name is Joe, age is 25, and height is 6.00. So these are the values which have been read. These are the values. So this is the example.txt file. So it contains three values. First one is a string, next one is an integer, and the last one is a float value. So these values are read by means of using scanf function, and then after that these values are printed on the screen. So by using these different statements. So in this way, we can understand the use of fscanf function. So this function, it reads formatted data from the file. So next one, there is another function we can make use of to read from the file. So fgets function. Fgets function, it reads the string from the file one line at a time. So it reads the string from the file. So here function prototype is, so fgets is a function name and it takes three arguments. So first one is a character pointer. The other one is, next one is an integer value, and the last one is a file pointer. So here file pointer name is the string. So here str is pointer to an array of characters where the string read is copied. So whatever the string we are reading, so that is copied to this pointer str. Then n specifies the maximum number of characters to be read or to be copied into, which are to be copied into the variable into this str. So including the terminating null character. So and then the stream, it is a pointer to a file object. So stream is a pointer to a file object which identifies the input stream. So fgets function, it returns a pointer to the string where the input is stored. Now let's see the use of this fgets function with the help of program. So this reads a string from the file one line at a time. So here we have defined a character array, that is a string. Name of the string is buffer, and maximum characters which it can store is 100. So including the null character. So here file pointer is fp. So fp is a file pointer. So in order to perform file related operations, we need to open the file. So we are opening the file by means of using fopen. So data.txt is the file which is opened in read mode. So whenever we open the file, so in our open function, we need to specify the name of the file followed by the mode in which the file has to be opened. Then after that, we need to check whether the file has been successfully opened or not. So that is done by means of using these statements. If it contains null value, that means the file is not opened successfully. So therefore, if it is opened successfully, then it will go to this line. So this line will be executed. So here by means of using fgets function, so it takes three parameters. So first one is buffer here. So buffer is nothing but the name of the string, you can say, or array of characters. So this is the name of the string or array of characters, and then size of the buffer, and then file pointer. If this is not equal to null, then printf. So this printf statement will print this buffer value. So this buffer is nothing but percentage. This is a string. So therefore we need to specify it with the format specifier is %s. So if this statement, so with this statement we'll get whatever the contents, what this buffer contains. So after that we need to close the file. After performing file read operation, after performing necessary operations, we need to close the file. So file close takes one argument as the input, and that is the file pointer fp. So when you run this program, so when we execute this program, we get the output as the number is 42. So why? Because we have opened the file data.txt in read mode. So data.txt, this is the file. So this is the file data.txt file which we have opened. So it contains the contents of this file are the number is 42. So the number is 42 here. So by means of fgets function, we are reading the whole string at a time. So what this buffer size is, maximum size of this buffer is 100. That means 99 characters can be read. So including the null character. So including the null character, the size of this buffer is 100. So maximum 100 characters can be read by means of this buffer. So here it reads, so whatever the contents of this data file are there, so those contents will be so that we are displaying on the screen. So therefore we get the output as the number is 42. So next one is fread function. So fread function is also a standard library function which is used to read the given amount of data from the file stream. So it is also defined in the header file stdio.h header file. So this is a function prototype. So it takes the return type of this is an unsigned integer, and it has these are the number of parameters it takes. So first one is a buffer. This is a pointer, void buffer. Next one is the size. It is in this type of this is data type of this is an unsigned integer, and count. This is also an unsigned integer, and the last parameter or argument is the file pointer fp. So buffer is a pointer to the memory area to be read into. Size is the size of each element in bytes, and count is the number. Count indicates the number of elements to be read. Then last one, file pointer. fp is a file pointer. So this is nothing but the pointer. So this file pointer is nothing but it acts as a reference. So that it acts as a reference to the opened file. So which has been opened by fopen function. So fopen. So this function, it returns the number of elements which are read successfully from the file. So if the return value is less than the count, it means that error has occurred or it has reached the end of the file. So if the value of size or count is 0, so then fread returns 0 and it does not perform and performs no other actions. So next is write to a file. So related to file IO operations, we can write to a file also, write data to a file. So these are the different functions which we can use for writing data to the file. So first one is fprintf function. So this is also a formatted function. Next one we have unformatted functions, fputs and fputc. Then one more function we have fwrite. So this is similar to printf function. So this function, it writes formatted data to the file. So we have printf function. So what it does is it writes formatted data to the screen, whereas fprintf, it writes formatted data to the file. Next, fputs function. So this function writes the string to the file. So whereas fputc, this function, it writes a single character to the file. So fwrite function, what it does, it reads specified number of bytes from the binary file and places them into the memory at the specified location. So writing to a file, first one, fputc function. So this function, what it does, it writes a character to the file. So it writes the given character, so at the position which is denoted by the file pointer. So after writing, the increment file pointer is also incremented. So let us see the function prototype. So here the return type of this is integer. Then fputc is the name of the function. It takes two arguments. The first one is the character. First one is an integer type. Name of the variable is char, and here the other one is pointer, file pointer. So here character is nothing but character which is to be written to the file, and pointer to a file object. The other argument or parameter is pointer to a file object which identifies the string where the character is to be written. Next example. So we'll see it with the help of an example. So f put c, if we write in this way, c comma fp. So here fp is the file pointer and c is the character which is to be written to the file pointed by pointer. So we can understand with the help of an example. So next one is fputs function. So fputs function, it writes the string to the file. So this is a function prototype. Return type of this is an integer, and it takes two arguments. One is a file pointer and other one is a string name. Other one is a point. This is also a character pointer. Next, fputs function, it writes the string to the file pointed by fp. Next, we'll illustrate the use of fputs function with the help of one program. So fputs function, it writes the string to the file. So here we have declared a file pointer. Name of the file pointer is file, F-I-L-E. So file is the file pointer. So next, after that, we need to open the file. So the file opened, which is opened is output.txt, that has been opened in write mode. So after opening, we need to check this, whether the file is opened successfully or not. So if the file is opened successfully, then, so this is a character pointer. So name of the character pointer is txt. So text text. So we are assigning it, we are initializing it with welcome to IARE. We are initializing it with welcome to IARE. Then after that, in the next line, we are making use of fputs function, and it takes two arguments, as we have seen. It takes two arguments. One is this character pointer and the other one is file pointer. So this is character pointer and the other one is file pointer. So when you get the output as, so this txt is assigned a value of, this is assigned a string value, that is welcome to IARE. So fputs, what it does is it writes this, it writes this entire string to the file. So entire string to the file. We have opened the file output.txt. So whatever the contents are, so those are returned to the file output.txt. Since we have opened the file in write mode, so therefore it will replace. So if there are any, if the file already has some data, so that data will be totally lost and it will be replaced by this data which we have written, welcome to IARE. So thus we can see that fputs function writes the entire string to the file. Next one is another function, fprintf function. So it is used to write data, formatted data into the file. So whenever formatted data means, so there we can use format specifiers. So this is a function prototype. So in the function prototype, name of the function fprintf, and it takes arguments. First one is a file pointer, fptr. Next one is a character pointer, str. And then we have the variable number of arguments. So these are the different number of arguments which are written, which have to be written to the file. So formats, this is nothing but format string. Let us see it with the help of one example. So this function, fprintf function, is used to write formatted data into the file. So this is a, first we need to open the file. So data.txt is opened in write mode. So this is the file which is opened in write mode. So if the file we are checking the condition whether it is not equal to null. So if it is not equal to null, then perform these operations. So number is assigned a value as, so variable num, which is an integer variable, that is assigned a value 42. This is initialization. Then fprintf statement, so it writes the data to the file. So what data is written? So data to the file. So that file pointer is given by this file. And then the second argument is, the number is, so this will be printed as it is. So this will be written as it is into the text file. So number is %d, corresponding to %d. So the value is given by %d is an integer variable. Corresponding value is stored in the variable num. So therefore, if you, with the help of this statement, these are the contents which are written to the file. So here, when you open the data.txt file, you will get this statements. So number is 42. After that, after performing necessary operations, we need to close the file. So in this way, we can write the data to the file by means of fprintf function. Next one is fwrite function. So fwrite function is also used to write data to the file. So generally the file here is a binary file. So function prototype is, so return type of this is an integer type, unsigned integer, and these are the arguments it takes. First one is a pointer variable. Next one is size, it is an integer variable, unsigned integer. Next one is n member, so it is this specifies the number of elements, and last one is a file pointer. So here ptr is pointer to array of elements which are to be written, and size is the size of basic data item, often specified by size of operator. So we can specify the size by means of, so we know that we can determine the size of any data type by means of using size of operator. So if you write in this way, so you'll get the size of integer variable. Next to this one is the number of elements, and fp is the file pointer which is returned. So that was returned by using fopen function. So this function returns the total number of characters which are written. So we can understand, so we can understand or we'll make use of this fwrite and fread function in the later videos. So these are the references. So until then, in the next video lecture, we'll discuss some more concepts of file handling in C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.